This video is over lesson 106, solving radical equations, and it's for my Algebra 1 class. So ladies and gentlemen, radical equations are just equations with a variable in the radicand. And the radicand is just the stuff inside of the radical. So we're going to go ahead and solve these, and generally speaking, for the most part, we just go ahead and use our typical SADMAP, our reverse order of operations to solve these. One of the things that we do need to watch out for is it is possible, once again, to have extraneous solutions. Now remember, an extraneous solution, you can think almost like an extra solution. And it's extra because it looks like it should be a solution. You can go through and do all of your work perfectly correctly, and yet you can still get these solutions out that aren't really solutions. They don't actually make the equation true. They look like they should, but they don't. So we do have to check all of our answers when we're solving radical equations, just like when we're solving rational equations. We got to check them. So to help us out with this, we are going to take a look at the practice problems. So let's go ahead and write practice. And then that's page 717 in your book. 717. And so let's dive in. A, we have the square root of x, or radical x, equals 6. So a radical is related to a square root, and the inverse of a square root is squaring. That's why we call it a square root. So if we square both sides, that should cancel out my root on the left here. So therefore x should equal 36. And if we do a quick check on that, radical 36 should equal 6, and of course radical 36 is 6. That's easy enough. So x equals 36 is our solution. B, radical 5x equals 15. Now remember, we're doing reverse order of operations to solve equations. So if we were to place x with some number, and you were to think through how you would do this according to the order of operations, what order you would do that in, whatever you would do first is what you'll actually do last in the reverse order of operations. Whatever you would have done last before, now you do first. So the last thing I would have done here is do the square root. So that means that's going to be the first thing I cancel out in reverse order. So again, to cancel out a square root, I'm going to square it. But whatever we do to one side, we got to do to the other. So if I square the left, I got to square the right. Over here, the square root and the square will cancel, leave me with just 5x. And then 15 squared is 225. Then I just got to divide both sides by 5, and x equals 45. Check for an extraneous solution. So radical 5 times 45 should equal 15. 5 times 40 is 200. 5 times 5 is 25. So 225. And sure enough, the square root of 225 is 15. That checks out. That is my solution. Letter C. We'll keep moving here. Letter C. Radical of x plus 3 equals 12. Now normally addition and subtraction are the first things we would take care of here. But however, because this is inside of the radical, you can imagine there being invisible parentheses around this, meaning that the x plus 3 would have been the first thing we do in order of operations, which means it's the last thing we do in reverse order. So once again, I got to take care of my radical first. So radical x plus 3 squared equals 12 squared. X plus 3 therefore equals 12 squared is 144. And now we just subtract 3 on both sides. X must equal 141. Check for extraneous solutions. 141 plus 3 should equal 12. That'll be 144 should equal 12. Square root of 144. Square root of 144 is 12. It checks out. D. I have the square root of 4x minus 15 equals 7. So once again, we do this in reverse order of operations. So the first thing I would have done in the order of operations is I would have multiplied the 4 times x. So that 4 will be the last thing I take care of. After I had done the 4, I would have then subtracted 15. So then I'll take care of the 15, then the 4. And then once I had done 4 times x minus 15, the last thing I would have done in the order of operations is square root. So if we reverse that, then the first thing I'm going to take care of is the square root. So the square root and the square cancel, leaves me with a 4x minus 15. Oops, sorry. And square the other side too. 7 squared is 49. Now, I'm going to follow my SAD map, so I'm going to take care of the adding before the multiplying. And so 4x then equals 64. Divide both sides by 4, and maybe some of you have this memorized. 64 divided by 4 is 16. Check for extraneous solutions. 4 times 16 minus 15 needs to equal 7. So 4 times 16 is 64. 64 minus 15, well, let's double check. So 64 minus 10 would be 54, minus 5, yep, was 49. It's always worth double checking yourself there. And then the square root of 49, sure enough, is 7. It checks out. So that's my answer. Oops, and I forgot to circle that one too. All right, I'm going to split my page here into 2 columns, try to save some space here. So E, letter E, we have the square root of 8, square root of x minus 8. X minus 8 equals 5. And you'll notice this time the radical does not extend over the minus 8, meaning that it's not part of the radicand. And so if we were to think this through, if we had some number that we were sticking here, let's just say 16. The first thing we would have done in order of operations then would have been the square root of 16. Then we would have subtracted the 8. So now we see here, because the 8 is outside of the radicand, it is going to be the first thing we take care of. So radical x equals 13. And now to cancel out the radical, I got to square both sides. And I don't know how many of you have this memorized, but you're going to see it enough times. You'll have it memorized soon if you don't already. 13 squared is 169. So quick check. 169, square root of 169 minus 8 should equal 5. So 169 square root is 13. And sure enough, 13 minus 8 is 5. It checks out. F. Square root of x plus 8 this time should equal 15. So again, because it's not part of the radicand, it means that we can go ahead and take care of that plus 8 first. And so I'll have the radical 8 equals 7, and then cancel out the square root by squaring both sides. So x therefore should be 49. So quick check. Square root of 49 plus 8 should equal 15. Square root of 49 is 7. And 7 plus 8, sure enough, is 15. G, we're going to keep rolling through here. 6 square root of x, 6 square roots of x equals 24. Same idea as the minus 8 and the plus 8 from the last 2 examples. Because the 6 is outside of the radical, that means I can go ahead and take care of it before I take care of the radical. So anything that's in the radical will be taken care of after the radical. Anything that's outside will be taken care of before we do the radical. So I'm going to divide both sides by 6 here. And so I'll get radical x equals 4. Square both sides. X therefore equals 16. Quick check. Square root of 16 is 4. And 6 times 4, sure enough, is 24. It is a solution. H. I have radical x over 3 equals 15. So, fractions mean division. In order to cancel out that divide by 3, we will have to multiply both sides by 3. So remember to do that. We leave this alone. This was your copying down the equation. Then here's my next step where I show the multiplication on both sides. And so that'll leave me with radical x equals 45. And then if we square both sides, I will get x equals my answer. Now hang on, don't grab your calculator just yet. Just a quick little side note, I'm going to show you a little trick when it comes to things that end in 5s when you square them. So if I square 45, little trick for this is because it ends in a 5, when I square it, it's going to end in a, we'll go ahead and put that in green. Okay, it's going to end in a 25. Now, because of this 4 here, because that's 4, and my blue's not showing up real strong there. Let's switch over. Let's try orange. There we go. That stands out a bit better. So because I got a 4 there, what I can do is I can take my 4 and multiply it by one number higher than itself. So 4 times 5 is 20. And so this will be 2025. That actually works every time. So if I had 35 squared, so 3 times 4 is 12, and it'll end in a 25. If I have 25 squared, 2 times 3 is 6, and it ends in a 25. You want to do 15 squared, 1 times 2 is 2, and it ends in a 25. For that matter, I could do 105 squared. So I'm going to treat this like a 10 in front of that 5. So 10 times 11 would be 110, but then I'll end in a 25. So it's actually 11,025. So nice little shortcut there. Can save you a little bit of time having to grab the calculator. So 45 again, 4 times 5 is 20. And then it ends in a 25. Put your comma in. So if I check my work here, 2025, square root of 2025 divided by 3 should equal 15. Well, sure enough, double check that square root of 2025. It is 45. And then 45 divided by 3, sure enough, is 15. On to the back. And I am looking at letter I now. Now letter I brings in 2 radicals. So if you have 2 radicals, what you want to do is you want to solve this if you can so that you've got the 2 radicals, one on each side. So this is actually perfect for us. I've got the square root of x plus 4 equals the square root of 2x minus 1. Now, since they're on both sides, I can just square both sides. So the square of the square root of x plus 4 and the square of the square root of x minus 1. So both squares will cancel both radicals, both square roots. That'll leave me with x plus 4. And over here, I'll have 2x minus 1. So I'm going to subtract x on both sides. Deal with your variables first. So 4 equals x minus 1. Add 1 to both sides, and 5 equals x. Quick check to make sure that this is actually true. And I'm going to get, and I want to write small because I like to try to get a second column here if I need it. So I've got 5 plus 4, shorten that just a little bit to save some space, equals 2 times 5 minus 1. So this would be 9. 2 times 5 minus 1 would also be 9. And I'm just going to simplify it all the way for good measure. So 5 is our solution there. J, we have the square root of x plus 5 minus the square root of 6x equals 0. So same idea here. I want the radicals on each side. So what I'm going to do is I'm going to add this term to both sides. So the minus and the plus will cancel out the square root of 6x. And I'm going to get the square root of x plus 5 equals the square root of 6x. Now I can take the square of both sides. And so x plus 5 should equal 6x. Subtract x on both sides. 5 equals 5x. Divide both sides by 5. And x should equal 1. Double check it. 1 plus 5 minus the square root of 6 times 1 should equal 0. So this would be the square root of 6 minus the square root of 6 should equal 0. And of course, something minus itself is 0. All right, J, we're on to K now. So for letter K, you'll notice for letter K, we've got something a little different here. This time we have an x in the radicand, and we have an x outside of the radicand. In this case, what you want to do is you want to solve for the radical. You want the radical to be isolated all by itself. So we're all set here. And we're going to go ahead and move forward and solve by squaring both sides. So if we square both sides, I get x minus 2 squared. And over here, I'm going to get x minus 4. I'm going to get the side squared. And ladies and gentlemen, you need to remember that exponents do not distribute over addition. This is not going to be x squared minus 4 squared. We're going to have to treat the entire side like a quantity and square it. So over here, my square will cancel, leaving me with just x minus 2. Over here, we're going to have to use the fact that a plus b squared is a squared plus 2ab. So ab, negative 4 times x would be a negative 4x. And then double that would be a negative 8x. And then plus b squared. So a negative 4 squared would be 16. So to solve this, remember one of the first things we want to do is set it equal to 0. So I'm going to subtract x on both sides here. And I'll go ahead and I'll let you add 2 to both sides as well. So x minus x is 0, negative 2 plus 2 is 0. So 0 equals x squared, and then there'll be a negative 9x, and 16 plus 2 would be 18. And so then from here, I got to think about, all right, now I've got a quadratic equation, and now how do I solve this? So we could use factoring to help us solve this. We could make a graph out of it to help us solve it, or we could use the quadratic formula to help us solve this. Well, factoring would be the easiest if it comes out nicely. So if I take a look at this real quick here, I'm looking for two numbers that when I multiply them together, I get a positive 18, but when I add them together, I get a negative 9, which means if we can find numbers out there, they'll both be negatives. Well, I'm thinking 6 and 3, 6 times 3 gives me an 18, but if they're both negative, it'll still be positive 18. But when I add a negative 6 and a negative 3, I get a negative 9. So sure enough, this is going to be x minus 6 times x minus 3. That equals 0. Then we split this. So x minus 6 equals 0, or x minus 3 equals 0. Add 6. X equals 6, or add 3. X equals 3. But now we need to check and see if either of these are extraneous. So if I start with my 6 here, and I'm just going to do this down here. If I start with 6, I've got 6 minus 2 equals 6 minus 4. So 6 minus 2 would give me a square root of 4, and that would be a 2, and square root of 4 is 2, so that checks out. So 6 is a solution here. X equals 3, so that would be 3 minus 2, square root of 3 minus 2, and over here 3 minus 4. So 3 minus 2 would be a square root of 1. 3 minus 4 would be a negative 1. Square root of 1 is 1. Oh. And so we found our first extraneous solution of the lesson. So x equals 3 is extraneous. So you can see this may not happen very often, but when it does, we need to be aware of it. So even though it looks like this should have 2 solutions, it really just has 1. We did all of our math correctly, but it does not have 2 solutions, just has 1. All right. And we got 2 more problems here to tackle. Let's try to fit it all onto one sheet of paper if we can here. So moving on to L. So for letter L, I have a square root of x plus 8 equals a negative 3. So since this is outside, I'm going to take care first. So subtract 8 on both sides. And then I have a square root of x equals a negative 11. And so then if we square both sides, x equals 121. Check for an extraneous solution here. I don't have room to do it next to it, so I'll just do it below. So square root of 121 plus 8 should equal a negative 3. So square root of a negative 100, or excuse me, square root of 121 is 11. And that is, not true. So that means that 121 is also extraneous. Well, there's no other solution that we found here. So if the one solution we have isn't truly a solution, that means there is no solution. So if the only solutions that you have found are actually extraneous, there is no solution. If you have multiple solutions, one of them is extraneous and the other isn't, then it's just the one that isn't that's the solution. All right. And finally, letter M. Last one, letter M. So M says, a breakfast nook has a planter along one side. The entire area of the nook is 42 square yards. What is the area of the planter? So what is the area of the planter? Oops, sorry. Appears my pencil just ran out of lead. I'm sorry, ladies and gentlemen. Give me just a second to load that back up. Apologize for this delay. And of course, this would be the time where it takes the longest in the world to actually get the pencil loaded back up. All right. So all right. So M, we have the figure that they have written there. So we know that we've got some areas. So our first area, the breakfast nook itself, is the square root of x squared. Each side is the length of the square root of x. And then we're going to add to that the area of the planter. And so the area of the planter here is 7 minus the square root of x for its length, and then its width is another square root of x. And so if we add those together, that gives me the entire area of 42 square yards. So I'm going to go ahead and solve then. So first things first, just simplify. So a square root squared will cancel, so that's just going to be x. And then over here, I'm going to distribute my square root of x in. So I get 7 square roots of x, and then minus square root of x times square root of x will just be, well, x. Keep simplifying, combine like terms. I've got an x and a minus x. Those will actually cancel each other out. So 7 square roots of x should equal 42. So now, if we divide both sides by 7, the square root of x should be 6. Square both sides. And so x equals 36. X equals 36. So if x equals 36, what is the area of the planter? So we're going to plug that in then. Well, first of all, we should check to make sure it's not extraneous. So I'm just going to do this one mentally. So that would be 6, which then squared would be 36. Over here, that would be the square root of 6 times the square root of 6. There's going to be square root of 36. Square root of 36, sorry, would be 6. Squared would be 36. Square root of 36 then would be 6. 7 minus that would be 1. And then square root of 36 again would be 6. So 36 plus 6 is 42. So that works out. And then finally, we want to find the area of the planter. So the planter is the 7 minus the square root of 36 times the square root of 36. And so if we simplify that, 7 minus 6 times 6, so it's really just 6 square yards. And that, ladies and gentlemen, is the end of our lesson.